Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent. Today we are going to discuss about some of the questions from your chapter, that is electricity. And in our previous lecture, we have a discussion about some NCERT questions. Now today we are going to discuss some of the NTSE questions that have been asked in your previous exams. So let's discuss the NTSE questions here that are from your NTSE and few Olympiad exams. So the first question in this sequence we have: a comb can run through one's dry hair, attract the small bits of the paper. This is due to. Now this is very interesting question and you have analyzed it in your day-to-day life. When you rub the comb in your dry hair and you have done this activity in your childhood time, that if you are going to attract the bits of the paper, you can see that these bits of the paper get attached to the comb. Why this happens? Because the hair in your oil will having some electrical charges, and due to this they will get some polarity and attract the bits of the paper which are completely neutral we have. So let us check the options here. Comb is a good conductor. This is not true. Paper is a good conductor. Again this statement is false. So these both are false. The atoms in the paper get polarized by the charged comb. So this is the correct option, because in our hair, when the oil is applied, they are having some charged particle, due to which the paper get polarized by having these particles. So this is our correct option. And the fourth option is the comb possesses magnetic property. This is entirely a wrong statement here. So which option is correct? We can say that option number C is correct. Now, let's move to the next question in this sequence we have. A wire of resistance R is stretched to twice of its original length. It means you are given a wire and you are stretching that wire to double of its length. So what I am doing here, I have a wire and the resistance of wire is R. Resistance of wire is equal to R, and you are just stretching the wire to twice of its length. So if I am considering the original length of wire L, original length of wire equal to L, then new length of the wire becomes 2L. New length of wire becomes 12. Now, you have to calculate its new resistance. Now, if I am going to calculate the new resistance, one thing you have to keep in your mind: if the wire is stretched to the double of its length or area is halved, whatever the conditions will be, the volume in both the cases must be same. So, what will be the formula for volume we have? Volume is having a formula that is equal to area into length. Volume equal to area into length. Now, if I am considering the previous volume, so our previous volume will be A into L. If I am considering about the new volume, the new volume will be A dash, but length will be twice here. Length will be twice here. So, if I am going to calculate the value of A dash from here, it came out to be A dash will be equal to A upon 2, because L will be cancelled by L. So what will be the new value of the area? It is equal to A by 2. Now, you know that you have a formula for resistance that is equal to R rho L by A. This is the factors on which the resistance basically depends upon. R is our resistance, rho is resistivity, L is the length of the wire, and A will be the area of cross section we have. So this is our previous resistance I am considering. Now if I am going to calculate the new resistance, that is equal to R dash. So what I have to substitute? Rho, resistivity will remain same because the material of the wire is same. Now what will be the length here? Length will be 2L, because we are just doubling the length. Area, this area will be our new area, that is our A dash, and the value of A dash I will substitute here. So R dash came out to be rho into 12 upon A upon 2. Again we are getting R dash equal to rho into 4 into L upon A. It means it came out to be R dash equal to 4 rho L upon A. And what I can substitute rho L upon A? I can substitute rho L upon A equal to R. So I can say that R dash is equal to 4R. So what you are obtaining here? You are just getting the new resistance that will be 4 times of the previous resistance in the wire. Now let us check the options here. Its new resistance will be 4R, R upon 4, 2R or R upon 2. So which is the correct option here? 4R, because the new resistance will be 4 times of the previous resistance. So this is again very interesting question we have. Just copy this solution from here. Now let's move to the next question in this sequence we have. Now, this is the question in which you have given the directions for the next two questions. In the following question, a statement of assertion is followed by the statement of the reason. So, this is a question which is basically a assertion reason type question. So, firstly, let's see the question, what question is saying. This is the question you have. A 60 watt bulb, 60 watt 220 volt bulb glows more than 100 watt 220 volt bulb when they are connected in series across a potential difference. When they are connected in series, resistance of 100 watt bulb will be more. So firstly, let's discuss the cases which are given here. This is our case 1 and this is our case 2. In case 1, you are provided with a 60 watt bulb having a voltage range 220 volt. And in this case, you are provided with a 100 watt bulb 220 volt. Now, the reason is they are connected in series and this bulb is glowing more as compared to this bulb. It means the glowing capacity of this bulb is more. It is glowing more. Now, when they are connected in series, the resistance of 100 watt bulb will be more. This is our reason. And the first question, what it is saying it is A, it means it is our assertion. This is assertion and this is the reason we have. Now, the first statement is correct that the 60 watt bulb will give you a more glowing capacity when they are connected in series. But when they are connected in series with the resistance of 100 watt bulb will be more, this is an entirely false statement. So what I can say here, assertion is true, but the reason is false here. So let's check the options here. Both A and R is true. R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, but R is false. A is false, but R is true. So which is correct option here? A statement is true, but R is completely false and it is not the explanation for the first statement. So our option number C will be correct here. Statement A is true, but R is false. Now, let's move to the second question of the reason assertion type we have. So, the second question in this series will be this. When a conductor is negatively charged, its mass increases excess of electrons on a body means the body is negatively charged. So firstly, write what assertion is saying. And second one is reason here. Now, what is the assertion saying? When a conductor is negatively charged, its mass increases. This is a true statement we have. If you have a more negative charge on the conductor, its mass will going to be increase. So, if there is more negative charge, mass will increase. Second part, excess of the electrons on a body means that the body is negatively charged. If you have excess electrons on a body, it means the body is negatively charged. Now, these both the statements are true here, but you can see that the second statement is not giving any explanation for the first one we have. So, let's check the options here. Both A and R are true, but R is the correct explanation of A. A and R are true, but R is not a correct explanation of A. A is true, but R is false. A is false, but R is true. So, which is the correct statement here? These both are true, but it is not the correct explanation for the assertion we have. So, we have the correct option here, that is option number B. That both assertion and reason are true, but R is not a correct explanation for the first one. Now, let's move to the next question we have. This is our next question. Now, the percentage error in measuring the voltage across a resistor small r by a voltmeter of resistance capital R, current is assumed to be the constant is. So, first write the given conditions here. The given conditions are, you have provided with a resistance small r, resistance of voltmeter is capital R, current is constant, and what you have to find out? You have to find out the percentage error. You have to determine the percentage error in this part. So, how you will calculate the percentage error? For calculating the percentage error in a system, we have a formula, and that formula is E minus V upon V into 100. This is a formula for calculating the percentage error. So, applying this formula, we will calculate the percentage error of this voltmeter. Now, this will be E minus V upon E into 100. So, we can write it as, if the value of E is not much large, we can write it as V upon E into 100. Now, you can see that you have to determine the percentage error in the resistance small r, and you are provided with a resistance capital R. If you are going to solve the parallel combination of the resistance, what you will get? You will get 1 upon R plus 1 upon small r. This is our R equivalent. Then the LCM will be RR, and you are getting R plus R. So, the R equivalent you will get in this case will be R equivalent in this case will be R plus R upon RR. This is 1 upon R equivalent, and R equivalent came out to be RR upon R plus R. So, this is the value we are getting here. Now, if I want to determine the percentage error in this system, what I have to do? I have to substitute the values of equivalent here. So, V equal to IR, and this will be our I into RR upon V equal to I into RR upon R plus R, and for that value, that is of the E, I can write here IR into 100. Now, from this equation you can see that I will be cancelled by I, R will be cancelled by R, and what I am getting here? R upon R plus R. So, this R plus R will be the percentage error that you will get in this voltmeter. So, what are the options here? 1 plus R upon R, 1 minus R upon R, 1 minus R plus R upon R, or R upon capital R plus R. So, this equation we are getting from here. So, this is the correct solution, that is option number D we have. So, this is the solution of this problem we have. Now, let's move to the next question in this sequence. The reading of the ideal voltmeter in the given circuit below will be. Now, this is our circuit and you have to identify the reading of voltmeter in this case. So, you can see that if I am considering the conditions to be the ideal, it means the no current will be flow in the circuit. So, what I can do? I can redraw the circuit. I can redraw the circuit with the zero conditions. So, what will be the circuit? This will be the circuit I am getting from here. This is our 20 volt. This is our 14 volt. This will be our 1 ohm and this will be our 2 ohm. Now, you can see that these are the batteries of same polarity. And if I am going in this direction, what I will get here, if I am assuming the current in this direction, what I can see that the voltage came out to be 20 minus 4. And what is 20 minus 14? 20 minus 14 will give me a 6 volt. Now, if I am removing the conditions from the middle side, you can see that these two resistance are in series. These are the series resistance we have. So, for the series, we have a formula that we will simply add the resistances here. It came out to be 3 ohm. Now, if I am going to determine the current in this circuit, then I will be our V upon R. V is 6 volt. R will be our 2 ohm and it came out to be 3 ampere. So, the current in this circuit will be 3 ampere. Now, again I am redrawing the circuit and applying the Kirchhoff's second law. So, what we are doing? Applying Kirchhoff's second law. Now, let's draw the circuit again. This is our battery. This is our resistance. This is our 14 volt battery. And this is our 1 ohm resistance. This is 20 volt. This is 14 volt. And suppose I am assuming that the current is flowing in this direction. Now, if we are going again in this direction, you can see that this is a 2 ohm resistance and the current flowing here is 3 ampere. Now, this is again our 20 volt battery. This is our 14 volt battery. 3 ampere is current is flowing in the circuit. So if I am going from this potential to this potential, what I have to do, I will just write VA minus, if I am going in this direction, I will write VB minus, this is our 1 ohm resistance. So 1 into 3 will simply give you 3 ohm, 3 ampere. Going in this direction, what you will get? 2 into 3, that is equal to 0. You have to calculate the reading of the ideal voltmeter in this circuit. So we will get that in going through this direction, we will assume that simplified redrawn circuit can be drawn as this is our 6 volt as we have subtracted from here. I am taking the direction of current like this, and this is our 1 ohm resistance here. 2 plus 1 will give you the 3 ohm. So I am connecting the resistance in series like this. Now, if you are going according to the Kirchhoff's law, if I am going to find out the direction in this circuit, the direction I am assuming here will be the clockwise. So what I am getting here, VA minus, the battery is 14 volt. Again, the potential drop will be calculated across this circuit will be 1, and current is found out to be 3 ampere in this case. So current here will be, current actually we have here 3 ohm resistance. So the current came out to be 2 ampere. So let's correct here this statement. This is 2 ampere we have. Now VA minus 14 and the current value is 2 ampere. So again it is drop, and drop can be written as IR equal to VB. Now VA minus 14 minus 2 ampere equal to VB. VA minus VB equal to 16 volt. So this will be the reading of the voltmeter that can be identified only by applying the Kirchhoff's law here. So what I have done, I have assumed ideal conditions. It means this part has been removed. These two connections, 20 minus 14 will give you the 6 volt. This 2 and 1 ohm will give you the 3 ohm resistance. From this resistance, I can calculate the current in the circuit, that is equal to V upon R, and it came out to be 2 ampere. Now, I have redrawn this simplified circuit, that is 6 volt, 3 ohm and current I. Now, if I am applying the Kirchhoff's second law, I can assume that this is having a VA polarity. So, VA minus, we are having the 14 volt battery here. This 14 volt battery and the drop in the circuit will be calculated from here, that is equal to 2 we have. Now, 2 into 1 will give you 2 ampere because this is a drop we are considering in this resistance only, and VB will be the potential of this battery here. So, VA minus VB came out to be 16 volt. So, let's check the options here, 14 volt, 18 volt, 16 volt or 34 by 3 volt. So, the correct option here will be 16 volt. So, this is the solution of this question. You can copy it from here. Now, let's move to the next question in this sequence we have. If the wire of resistance 1 ohm is stretched to double of its length, then its resistance will be. So, this is the same question we have done earlier, but the resistance there is R ohm. So, here the resistance provided is 1 ohm. Resistance is 1 ohm. Now, you are stretching it to double the length. So, the length will be 2L. So, R will be rho L by A This will be the formula for resistance we have. I have told you earlier that the volume you have to keep the same. So, A into L will be equal to A dash into 2L. So, the value of A dash came out to be A by 2. This is the earlier case we have done. And on substituting this value, if I am considering the new resistance to be R dash, it will be equal to R rho, length will be doubled, area will be A by 2. It came out to be 4 rho L by A. So, you can see that the new resistance will be 4 times of the previous resistance. This is the same question we have done earlier, but here the value of the resistance given is 1 ohm. So, the new resistance will be R dash equal to 4 into 1 and it came out to be 4 ohm. So, the correct option here will be option number D we have. So, this is the solution of the question we have. This is the same question we have done earlier. So, just copy this solution from here. Now, let's move to the next question in this sequence we have. Voltmeter inverse is the unit of what you are given? You are provided with voltmeter inverse. So, I can write it as volt upon meter. Now, the volt will be the unit for potential and meter will be the unit for length, and electric potential per unit length is termed as electric field intensity. It is termed as electric field intensity. So, let's check the option here. Potential we have a unit volt, electric field intensity, this is the correct answer. Electric current will have a unit ampere and potential energy will have a unit of joule. So, the correct option here will be electric field intensity. Now, let's move to the next question in this sequence we have. What will be the power consumed by a 25 ohm wire if connected across a 250 volt main supply? First, write the given conditions here, what you are provided with. The given conditions are, you are given a resistance of 25 ohm. You are given a supply of, that is V equal to 250 volt. Now, what you have to determine? You have to determine the power in this case. So, power is having a formula VR, or we can say that P equal to V upon R, I square R, or power is equal to V upon R. This is the formula for power we have. Now, if I have to calculate the power here, what I am doing here, 250 power will be I square R or V square by R. So, V square will be our 250 into 250 and the resistance will be our 25 ohm. Now, it came out to be 10 and what I am getting here? I am getting here power equal to 2500 watt. So, this is the power we are getting here. Now, you are provided with the power in watt and kilowatt. So, I am converting it in the kilowatt. So, 1 kilowatt power will be equal to 1000 watt. So, 2500 divided by 1000 will give you 2.5 kilowatt power. So what I am getting here? I am getting the power here that is equal to 2.5 kilowatt. So option number 1 is 2.5 kilowatt. So this is the correct answer in the kilowatt. But what we are getting in watt? We are getting 2500. So there is no option that is showing the 2500 watt power. So this is our 2.5 kilowatt. Let's discuss the next question in this sequence we have. The next question is 1 electron volt is equal to. So the 1 electron volt, that is 1 eV, will be equal to the charge on the electron we have. So it must be your energy in the joule. So 1 eV is equal to 1.6 into 10 raised to the power minus 19 joule. So which is the correct option here? Option A is the correct. So you have to just remind that 1 eV in energy will be equal to charge on electron. So this is the charge on the electron and this will be your energy in the EV. Now, let's move to the next question in this sequence we have. In the circuit diagram shown in figure, you have to determine the ratio of current flowing in the upper arm and the lower arm. This is our upper arm. And this will be our lower arm. Now, for determining the current, firstly, you have to determine the equivalent resistance of both the system. So, you can see that these two resistances are connected in parallel. These two resistances are connected in parallel. So, I am determining the RP in this case. So, I am writing here in upper arm 1 upon RP will be equal to 1 upon R1 plus 1 upon R2. This is the formula for parallel combination we have. So 1 upon RP plus 1 upon R2 will give you 1 upon R plus 1 upon R. And 1 upon RP will be equal to 2 upon R, and the value of RP came out to be R upon 2. So this is the resistance in the first arm. In the lower arm, you can see that 3 resistances are connected in the parallel. So what I am taking here in case 2 in lower arm. In this lower arm, we have the 3 resistances. So 1 upon RP dash will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And you can see here the value of all these 3 resistances are R, R and R. So 1 upon RP dash will be equal to 1 upon R plus 1 upon R plus 1 upon R. So what it give you? It will give you 1 upon RP dash equal to 3 upon R. So the RP dash came out to be R upon 3. So this is the resistance in the lower arm. Now, what you have to determine, you have to find out the ratio in both the arms, ratio of the current. You can see that here the battery connected plus minus V will be same to both the circuits. So, for first arm, I am calculating current in the lower arm. The current in the lower arm will be I equal to V upon R, that is equal to RP, and the current in the, this is the current in the upper arm. This is IU, and this is our IL in the lower arm, that is equal to V upon RP dash. Now, if you want to determine the ratio of both these currents, you have to divide IU by IL. So what I am getting here, I upper upon I lower equal to V upon RP upon V upon RP dash. So what will happen here? V will be cancelled by V, and IU upon IL I will get from here, that is equal to RP dash upon RP. What is the value of RP dash? It is R upon 3. And what is the value of RP I am getting here, RP I am getting here is equal to R upon 2. R will be cancelled by R here, and what will be the ratio of the currents? The ratio of the current came out to be 2 by 3. So, the ratio of current flowing in both the arms will be 2 upon 3. So, I can guess here that the option 1 is the correct. So, we can say that the ratio is 2:3. So, what you have to do in these numericals, you have to just simplify the combination of the resistances you have provided. In the upper arm, we have the parallel combination. In the lower arm, again we have the parallel combination, but we have a common source of battery having a voltage or EMF that is equal to V, and we have just divided these two equations. This is our equation number 1 and this is our equation number 2. Just copy this solution from here. This is again very interesting and important question you have. Now, let's begin with the next question in this sequence we have. Again, you are provided with a combination of the resistances in this circuit diagram. What will be the equivalent resistance between point A and B in this given circuit? This is our point A and this is our point B, and you have to determine the equivalent resistance. So, you have to solve this structure for finding out the equivalent resistance in the circuit. Now, you can see from there that this is our resistance R, and they both are connected in a single line. So, what I can do here, I can just draw it as R, this is our R, this is our point A, and this is our point B. This is R, this is R, and R. Now, you can see that the first two resistances are connected in series. I can say that these two resistances are connected in series, and these two resistances are in series is parallel with that third R. This is our third R. So, I can write here, this will give you R plus R, that is equal to 2R. Here RS came out to be R plus R, and this will give you 2R. This is our point A, this is our point B, again this is R, this is our 2R, and this is our R. Now, see in second diagram, this is our redrawn circuit diagram 1 and this is redrawn circuit diagram 2. Now, you can see that these two combinations are in parallel. These two resistances are in parallel. So, for the parallel, I am just applying the formula. 1 upon Rp will give you 1 upon 2R plus 1 upon R. LCM came out to be 2R. LCM will be R, and you will get here 2 plus 1. So, 1 upon Rp will be equal to 2R by 3. Rp came out to be 2R by 3. Now, This is our 2R by 3 resistance in this parallel combination, and again you have the two resistances connected here, R and R. Now again redraw the circuit, that is your step number 3. This is our point A, this is our point B. You have these two resistances in these arms. So this is our R, this is our R, and it is our 2R by 3. Now you can see that if you want to determine the equivalent resistance between A and B, these all are in series. So I can write that RAB equal to R plus 2R by 3 plus R. It will be equal to 3. It will be equal to our 3, and this resistance came out to be 3R plus 2R and 3R. So it will be equal to 8R by 3. Here I have just taken a LCM. So it will be our 3R, it will be our 2R, and it will be our 3R. So 3 plus 3 plus 2 will give you 8. So the equivalent resistance between A and B points came out to be 8 ohm by 3, that is equal to 8R by 3. So let's check the options here. 5 upon 3R, 2R, 8 upon 3R or 3R. So the correct option here will be 8 upon 3R. Now let's see this circuit again. These two combination are in series. This is our first diagram. In second diagram, the series is in parallel with that R. So we have calculated the parallel resistance here. Now these three resistances will be connected by the single wire. So I have redrawn the circuit. That will be a single wire. In equation number 3 we have, and RAB came out to be 8R upon 3. So RAB will be our 8R upon 3. So you can copy this solution from here. For simplifying such circuits, you have to draw the re-circuits again and again, because these complex circuits can be analyzed only by redrawn the circuits again. Now let's move to the next question in this sequence we have. According to the Ohm's law, the graph of the potential difference and current is. Now you have seen in the Ohm's law, we have just plotted the graph. Here we have taken the voltage, here we have taken the current values, and according to the Ohm's law, it is following the curve like this. It means this is a straight line curve. This is a straight line graph which is actually starting from origin we have. So this graph basically starts from origin we have. So let's check the options here. It is a straight line passing through origin, curved, line having an intercept on x-axis, or circular. So the correct option here will be, it is a straight line passing through origin. So this is a theoretical question we have in our chapter. Now let's move to the next question in this sequence we have. If resistance are connected in series, this is again a theoretical question. If resistance are connected in series, different current flows through every part and effective resistance is greater than the individual resistance. Same current flows through every part and effective resistance is smaller than individual resistance. These two statements are entirely wrong, because in series connection, the same current flows through every part and effective resistance is always greater than the individual resistances. Third option is same current flows through every part and effective resistance is greater than individual resistance. This is our truth statement. Fourth, different current flows through every part. In series resistance, we have only provided with the single current. So the same current will be passed through all the resistances. So here option number C will be our correct answer. Now Next question in this sequence we have, in an electrical heater 1500 watt is marked. So let's write the given conditions here. In an electrical heater 1500 watt is marked. It means power here is 1500 watt. If this heater is used for 10 hours continuously, then what will be the consumption of energy? What you are provided? Next thing, you are given with a power, time and power you are provided with. So you are provided with the two factors here. Then you have to calculate the energy consumption. What you have to determine? You have to calculate the energy consumption. Now, for calculating the energy, what you will do, you will just multiply the power with the time, because this is what you have a calculation formula for calculating the electrical bill also. So, energy consumption will be equal to power into time. So, power is 1500 and time is 10. So, what I am getting here? 15,000 watt hour. Now, if I am going to write it as 15 kilowatt hour, it means I have converted the watt into kilowatt hour by dividing it by 1000. And do you know that kilowatt hour is a basic unit that is called unit in our homes. If I am consuming 15 kilowatt power, I can say that the power used is 15 units here. So, 15 kilowatt can be written as 15 units. So, let's check the options here. 30 unit, 40 unit, 15 unit and 19 unit. So, which is the correct option here? Option number C is correct here. Now, let's move to the next question in this sequence we have. This is our new question. The length of the wire of a material is L and area of cross section is A. So, first write the given conditions here. The given conditions are, you are provided with length of wire. Length of wire is small l. Area of cross section is A. Area of cross section equal to A. Resistance of the wire is 4 ohm. Resistance of wire is 4 ohm. Now, this is all about our case 1. This is our case 1. Now, what actually happens in the case 2? The length of the wire is L by 2. Now, the new length is L by 2. Area of cross section is 2A. What is the new area? New area we will have is 2A. Then, what will be the resistance in case of second one case? Now, you have to determine the new resistance. Now, you have actually a formula of resistance that is equal to R equal to rho L by A. This is the formula for calculating the resistance you have. So, if I am calculating the R new, you can see that rho will remain constant. What you have done? You have just halved the length. So, the new length will become L by 2 and you have doubled the area. So, it will become 2A. Now, R new will be equal to rho L upon 2 and you have just twice the area. So, it is equal to 2A. Now, I can write here R new equal to 1 upon 4 rho L by A. It is 1 upon 4 rho L by A. So, what I am getting from here? I am just getting from here that the new resistance you will getting in this equation will be rho L by A, and it will be the 1 upon 4 times of the previous resistances in the wire. So, R new equal to 1 upon 4 R previous. This is our resistance, that is the previous one. So, the R new came out to be 1 upon 4 and the previous resistance of the wire is 4 ohm. So, it is our 4 ohm, 4 will be cancelled by 4 and the new resistance came out to be 1 ohm. So, let's check the options here. 2 ohm, 3 ohm, 4 ohm and 1 ohm. So, here option number D is correct one. So, how from the previous resistances we can calculate the new resistances just by changing the few conditions here. So, let's copy this solution from here. Now, let's move to the next question in this sequence we have. Fuse wire should be placed in the path of. So, if you want to connect the fuse wire in the circuit, you just have to put it with the phase. So, this is a very common question. You have to learn that the fuse will always be placed with the phase. Let's check the options here. Neutral, phase, earth or none of these. So, here the correct option is phase. So, you have to keep the fuse wire with the phase wire. Now, the next question in this sequence we have the average drift velocity of electrons in a wire when it is not connected to the cell. When the system is not connected to any battery, it means there will be no drift electrons in the system. So, the value of the drift electrons will be 0. So, the correct option here will be 0. Average drift velocity in a wire when not connected to a cells will be 0. Now, let's move to the next question in this sequence we have. Most of the power stations produces. So, we have discussed about the alternating current and the direct current. So, we have just seen that the most of the power stations, it means 90% of the production of the energy is always in the form of the alternating current. So, which is the correct option here? Direct current, electric power, potential difference and alternating current. So, we have the correct option, that is alternating current. Now, let's move to the next question in this sequence we have. Two lamps A and B are rated like this and you have to calculate the ratio of the heat produced. So, I am writing it as lamp number A and lamp number B. What you are provided with? Power 100 watt and voltage 220 volt. Here power 60 volt and voltage 220 volt. Now, you have to determine the heat produced in lamp A and B. Now, if you have to calculate the heat produced in A and B, firstly, what you have to determine, you have to calculate the resistance of the circuit. So, the resistance will having a formula, you have to calculate the resistance in both cases. Then, power is having a formula that is equal to V square upon R. So, the R must be equal to V square upon P. It came out to be 220 into 220 upon 100. 0 must be cancelled by 0 and it is equal to 484 ohm. In second case, R will be V square by P. It came out to be 220 into 220 upon 60. 0 will be cancelled by 0 and it came out to be 4840 upon 6. So, this is the resistances in both the cases. So, this is the resistance of lamp A. So, I am denoting it as RA and this is the resistance of lamp B. Now, if you want to calculate the ratio of the heat produced in the circuit, so the formula for heat is I square R. Now, if the heat is producing in the lamp A, it must be I square Ra. If heat is produced in the lamp B, it must be I square Rb. Now, if I am going to find out the ratio of heat produced in A and B, it came out to be I square Ra upon I square Rb. Ri will be cancelled by I. Ra is having a value 484 ohm and Rb is having a value 4840 ohm upon 6. So, it must be cancelled by this and it came out to be 6 upon 10. And 6 upon 10 will give you a ratio 3:5. So, which is the correct option here? A, 3:5 is the correct option we have. So, the heat produced is basically calculated by the formula I square R, but for that you have to calculate the resistance in both the cases first. So, just copy this solution from here. So, these are few of the NTSE questions we have discussed in our today's lecture. These questions are very important. So, go through this video lecture very clearly. So, every step you solve, you must have to remind every formula here. So, this lecture is over for today. Thank you so much and have a nice day.